Bailey with the Knox County Public Library Tutor Team, and I am here today with another video lesson covering kindergarten and first grade academic standards with a math video lesson. So here are the specific and grade level specific academic standards for kindergarten and first grade, and these standards are specifically working on number sense skills. If you are interested in looking at additional grade level specific academic skills for other grade levels or more content areas for kindergarten and first grade, you can visit the DOE.in.gov website to find those. Okay, before we get started, I always like to give some tips to parents on how to differentiate these video lessons because we have lots of different learning styles, and because we are covering a wide range of learners through multiple grade levels, kindergarten and first grade, and also I always like to encourage parents to use these videos if you notice that you have maybe a second or a third grader who could use some extra practice on these skills. Just because they're kindergarten and first grade standards doesn't necessarily mean that your learner, if they are older, wouldn't benefit from some extra practice. We want to be appropriate, and you might find that your older student, this would be appropriate for them. Okay, so if you want to pause and kind of take a look through these suggestions, the way that I have them organized is the level of difficulty is based on how many purple dots you see. So this set of suggestions with the one purple dot is the easiest set of modifications to help learners with this video, kind of to work their way up to completing the video with ease. Number sense is one of the things that number sense and number formation, just like letter formation, is very important because a lot of the times you'll notice that your learner, they might be able to write the letters down, the numbers down quickly, but they're not necessarily forming them correctly, and that can get in their way sometimes, and it can be a discouraging factor in wanting to do their work sometimes if writing is something you're noticing that your learner kind of tries to avoid. One of the first things that I look at as a teacher is their letter and number formation, because there might be a reason they're avoiding it, and the first kind of roadblock a lot of the times is if they're not comfortable with how they make their numbers or letters. So here's a guide that kind of shows you which location to start the number and then which direction to go. That's an appropriate skill for all level of learners to be able to practice. That's always good practice. Now, these suggestions are for learners who are finding these lessons a good fit. Maybe they just need to pause or replay a little. And then the three purple dots are some suggestions for learners who are ready for a little bit more of a challenge. All right, learners, let's talk about what a good mathematician looks and sounds like. And if you notice, this looks just a little bit different from our last video and what good mathematicians look and sound like. I've changed a couple things and I've added something. So we always keep our goal in mind, and that light bulb symbol shows us, hey, this is a really great opportunity for me to use my goal. So we don't just talk about our goal at the beginning of the lesson. We do that for a reason. We talk about our goal at the beginning of the lesson so that throughout the lesson, we're keeping it in mind. And then we talk about it at the end too, to kind of reflect on how hard we worked on it and how many times we were able to do it successfully? Are we mastering it? Do we still need some extra practice with it? Mathematicians use their tools like 10 frames and number bonds. They stay organized by doing things like circling groups of 5. They use their time wisely by drawing quick pictures. So instead of drawing exactly what you see, just do it quick. We got to use our time wisely. They make mistakes. They try their best. And the one that I added this week is the strategy that we started talking about in our last video, using our counting sticks or our fingers to count on. That is a good shortcut strategy that good mathematicians can use instead of, just kind of sitting there and racking your brain and thinking, oh, I don't know, what is it? I think I know it. No, take some action, get a running start, okay, with a strategy like counting on, using your tools. You'll need these materials, a pencil and some paper. We're ready to review some mathematician vocabulary. So, really important, staying organized. If you want to pause and take a look at some of the examples of how we have stayed organized with our math videos, go ahead and do that now. Press play when you're ready. Here's that counting on strategy that we started using in our last video. Okay, so using your counting sticks or your fingers, okay, we can use our fingers as tools, and that's when we call them counting sticks. Now, this is just one strategy that good mathematicians use. I want you to be able to have a whole tool belt of strategies. So this is just one. We say the number that we know, and then we count on to get to the number that we're trying to find the whole amount for. Okay, so last time we worked on describing parts in groups of 8 and counting on. So with, like, if we know one of our parts is 5 and we want to have a whole amount of 8, so we say 5 and we count on with our other counting sticks until we get to 8. 5, 6, 7, 8. So how many did we have to add on? 3. So there we go. We counted on. And that's how we use that strategy. It can be a shortcut. Okay, some more shortcuts we've been talking about with our fact power. Patterns that we've noticed. Any number plus 0 always equals itself. Any number plus 1 will always equal 1 more than itself. And then we have been practicing facts or number partners that are describing parts in groups of 5, 6, 7, and 8. Today, we're going to be practicing describing parts in groups of 9. Okay, so before we talk about today's goal, really quick, I just want to go through all of the facts that we have practiced, and I want you to see how strong you are getting with your fact power muscles. So I want you to kind of use these as flashcards. So pause the screen, go through these. So if you're pausing this, here's an example of what you might be practicing on your own. You could say 0 plus 5 equals 5. Another way to read that, rearranging the parts, but still telling the truth so that they equal a whole amount of 5. 5 is the same as 0 plus 5. Okay, so these are just, they're all the same number sentence. They're just showing the same number sentences, the same number sentence in the different ways that it can look. So these are the practice facts that we have practiced to describe parts that make up groups of 5. So here we have For instance, 1 plus 4 equals 5, or we could say 1 more than 4 equals 5. Okay, again, I want you to take some time with these, so pause and go through these facts on your own. Two plus 3 equals 5, or another way to say that would be 2 and 3 more is the same thing as 5. Our math symbols, remember, we can switch out and use the words that mean the same thing. Okay, here are some facts that we've practiced that are number partners that are describing parts that make up a whole amount of 6. So here's that pattern again. Any number plus 0 is going to equal itself. So just like when we added 0 to 5 and we got 5, if we add 0 to 6, we get 6. 1 more than 5 is 6. Another group of number partners that describe parts in groups of 6 would be 2 plus 4. And then here are the turnaround facts that represent that same story, that same number partnership of 2 and 4 describing parts in groups of 6. We could also do 3 plus 3 more equals 6. Now, you'll notice there's only 2 number sentences here because if we flip-flop, this is a double, 3 and 3. If we flip-flop those, it'll look identical. So this is a double, and we'll talk about those in a different lesson. All right, we have also worked on parts describing groups of 7. So again, 0 plus any number is going to equal itself. 0 plus 7 equals 7. Any number plus 1 is going to equal 1 more than itself. So 1 more than 6 is 7. Another pair of number partners that work together to describe a whole amount of 7 is 2 and 5. Three plus 4 also go together to equal 7, or we can flip-flop that and do 4 plus 3. All right, last week, so this is the latest set of facts that we've worked on. Last week, we were describing parts in groups of 8. So let's go through those facts together. 0 plus 8 equals 8. Or 8 equals 0 plus 8. Remember, we can put our whole amount in the front of the addition number sentence with the equal sign, just as long as we're telling the truth. Are our parts going to equal the whole amount? Do we have our number symbols, our math symbols, are they in the correct spot? Okay, 1 more than 7 equals 8. Another number partnership that describes parts in groups of 8 are 2 and 6. Can you think of another one? Another group of partners, number partners that equal 8? 3 and 5. There's another one. Yeah, 4 and 4. And again here, guys, you just see 2 different ways to show this addition number sentence because this is another example of doubles. Double is when you have more than one, so actually not just more than one, but 2 of the same thing, like twins. Okay, so if we were to flip-flop 4 and 4, it would look exactly the same. So that's why I just showed 2 number sentences here. All right, we're ready to talk about today's goal. So, mathematicians, we are organizing our thinking using math tools. so that we can build our fact power. And our goal will be achieved when we describe parts in groups of 9. Today we're working on describing parts in groups of 9. Okay, take a look at this die. So if you just have one, it's just a die instead of dice. How many dots do you see here? Okay, we had 6. Now, if I wanted to roll another die, so that I had dice, to describe another part to work together with 6 to make a whole amount of 9, which of these dice would be the correct amount to add? So if I'm starting with 6, what could I do to figure out how many more dots I would need to equal 9? Okay, so as you're thinking about that, go ahead and get your paper and pencil ready, and we're going to draw our number bond. We're getting really good at these number bonds. All right, so back to our original question. If I start with 6, that's my first part. So you can go ahead and fill that part in on your number bond. I'm starting with 6. I want a whole amount of 9. Because remember, our goal is I describe parts in groups of 9. So we want to equal a whole amount of 9. We know we have 6. Let's use that strategy that we started talking about last week, where we count on. Okay, so if I have 6 already, say 6, and let's use our counting sticks to continue counting on until we get to 9, which is our target number. That's the number we're trying to describe parts of today. So say 6, that's what we're starting with, 6, 7, 8, 9. How many did I count on to equal 9? 3. So maybe you already found that that was the correct amount of dots to add. Really quick though, let's go through and double check all of our choices. So what if we added 6 plus 2? What would that give us? Say 6, count on 2 more. 6, 7, 8. Are we trying to describe parts in groups of 8 today? No, that's not it. So that doesn't work. Okay, that doesn't work. Let's try our next choice. How about 6 plus 5? All right, say 6. Let's count on 5. 6, 7, 8, 9, 10, 11. That doesn't work because remember, guys, we're trying to get to 9. 11, that's bigger than 9. That doesn't make sense. We still have one more option. Let's try the last option, 6 plus 3. So say 6. Give me 3 of your counting sticks. Say 6. Let's count on 6, 7, 8, 9. That was the number we were trying to get to. So is that the correct choice? It sure is. Ding, 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 ding. That's the correct answer. Okay, so here's our number bond with the parts we know. We want a total of 9. That was our target number. We knew we had 6 to start with. We have to add 3 to complete describing the parts that add up to 9. So here are those number sentences or those partners, those number partners that we just worked on. We could say 3 plus 6 equals 9. We could flip-flop it and turn our parts around and say 6 plus 3 equals 9, we could put the total amount in the front, 9 equals 3 plus 6, or we could say 9 equals 6 plus 3. Okay, we just added another fact to our fact power. Good job, friends. Let's look at another problem. Okay, taking a look at this 10 frame with your math detective eyes. How many do we have here? I see a row of 5, 6, 7. So notice how I didn't count one at a time. As mathematicians, we want to try to take shortcuts, work smarter, not harder. So we know in a 10 frame that first row is a row of 5. So you know that, say 5 and then count on 5, 6, 7. So we have 7. We want how many total? We want 9. So taking a look at our options here, which of these dot amounts would we need to add to the part we already have to equal 9? Okay, keep that in your head. We need to draw another number bond. There we go. Okay, so let's take a look at our options here. We start with 7, so let's look at that last choice, or I should say our first choice. Say 7, give me 4 counting sticks. Let's say 7 and count on 7, 8, 9, 10, 11. So if I add 4 on to my 7, that's too much. That doesn't make sense. I'm trying to get to 9. That wouldn't equal 9. That would equal 11. So that's not right. So good mathematicians also, they check their work by going through, and this is called eliminating choices. So we know we can eliminate or get rid of that first choice because it doesn't work. We know that because we tried it out. We know it doesn't make sense. Okay, looking at our second option, if I have 7 and I add 2, so say 7, give me 2 counting sticks, and we're going to count on 7, 8, 9. Is that what we were trying to get to? Does it work? The 7 plus 2 describe parts in a group of 9? It sure does. Now, does that mean we shouldn't double check our last choice? Good mathematicians look at all their choices just to be sure. So let's look at that last choice. Say 7, give me 3 counting sticks. 7, 8, 9, 10. Doesn't work, does it? But it's good that we double checked. So 7 plus 3 more would equal 10. That's not what we were going for. We were going for 9. So here are the parts that correctly describe the parts in a group of 9. Okay, here's another look at some facts that we're adding to our fact power muscles. 2 plus 7 equals 9 is one way we could write what we just did together as a number sentence. We could also flip-flop the numbers and do 7 plus 2 equals 9. Or we could even put the whole amount in the front, as long as we're telling the truth and using our math symbols correctly. It is true that 9 equals 2 plus 7. And it is true that 9 equals 7 plus 2. Those fact power muscles are getting so strong. Good job, guys. Okay, let's look at another practice problem. How many do you see in this 10 frame? Again, my goal for you is not to have to count one at a time. Okay, now that's better than just guessing, but I want you to think. Give me your finger. Think. What do you know about 10 frames? We know that each row has 5. So if you see a row completely filled in, that tells you right away, oh, I have 5. Okay, so we're starting with 5. We want a total of 9. So here are some choices. Which of these would add up to a total of 9? Remember, our goal is to describe parts in groups of 9. So if we already have 5, how many more do we need to equal 9? We need one more number bond for our practice problem. Step 2, step 3, step 4, and the last step. And we are ready to rock and roll. So let's try out our choices. If I have 5 and I add 2 more, let's use that strategy of counting on. Say 5, give me 2 counting sticks. So notice how I'm saying the bigger number. So I'm working harder. I'm working smarter, not harder. So this is the shortest, quickest, easiest way to do it. Say 5, the bigger of the 2 numbers, count on 2 more. 5, 6, 7. Is that what we're going for? Is that our target number? No. So that doesn't work. We're not describing parts in groups of 7 today. We're describing parts in groups of 9 today. I'm going to go back to that one. So guys, I want you to notice 5 plus 2 equals 7. That is a correct number sentence. Okay, the reason that X is under the 7 is to show that's not what we were wanting. That wasn't our target number. Our target number, the number we're going for, is 9. Okay, let's try this. Let's add 5 to our 5. So say 5, give me 5 counting sticks. Count on. 5, 6, 7, 8, 9, 10. One too many. Okay, we're not going for 10. Not yet anyway. So that doesn't work. Again, it is true that 5 plus 5 equals 10. That's a true number sentence. The reason why that red X is there is because that's not our goal today. Our goal is to describe parts in groups of 9. Let's try that last one. What about 5 plus 4 more? Say 5, give me 4 counting sticks. 5, 6, 7, 8, 9. Silent celebration. Okay, there we go. That worked. We tried each one and we found our correct answer. So here are the facts or the number partners that show or represent or model another set of parts that describe a group of 9. So we could say 4 plus 5 equals 9. We could flip-flop the parts and say 5 plus 4 equals 9. Or we could put the whole amount in the front and say 9 equals 4 plus 5. 9 equals 5 plus 4. That was a good workout, friends. Mathematicians, I hope you are feeling the burn because you earned it. You are so strong with that back power. Okay, the patterns we've worked on. Any number plus 0 always equals itself. Any number plus 1 will always equal 1 more than itself. We've practiced describing parts in groups of 5, 6, 7, 8, and now we can say that we've also practiced parts that describe groups of 9. That's a lot of facts, friends. So here's some more number partners that we didn't do a practice problem that represented these number sentences. So here are some more number partners that go together to describe parts in groups of 9. 0 plus 9 equals 9. 1 more than 8 equals 9. And then we also can partner up 3 and 6. Well, actually, I think we did that. We did do a practice problem that described that. 3 plus 6 more equals 9. Okay, our goal today, let's go back to that goal. We're wrapping it up here. We're cooling down, just like a real workout. We're cooling down, friends. Okay, today we organized our thinking using our math tools. So we used the math tool, the number bond. We also used strategies like counting on so that we could continue building our fact power. And we did that today by describing parts in groups of 9. I'm so proud of you guys. I hope you're proud of yourself. You have really been working so hard. Think of how many facts that is now that you know, those number partners that you know. Okay, everybody, my mathematicians, thank you so much for joining me today to practice those facts and your math skills. Okay, if you want to watch this video or videos that came before this, because I always ask that you don't skip any videos, okay? So like with the math videos, make sure that you watch them in order, okay? Just like the reading videos. You can find them on YouTube, on the Knox County Public Library, the KCPL Tutor Team site. The link is right here. There's a playlist of all of the videos, and they're organized by the teacher. Okay, so you'll also see my really cool friends, Mr. Frederick and Mrs. Warland, who have other tutor team videos that cover grade level specific academic standards for 2nd, 3rd, 4th, and 5th grade. So our videos are covering kindergarten and 1st standards, but we also have videos from the KCPL tutor team that cover older grade level standards. All right, friends, thank you so much again for joining me today, and I will talk to you soon. Have a great day.